Right over there. Hello, everybody. Welcome back to Mind Body Evolution. This is Dr. Josh Stout, and it's been a while. There's been a lot that's happened in the news, but we're not going to talk about that.
We're definitely not talking about that today. No, I just want to move on to different directions. I've just started a new semester. I'm doing a research-based class, and I'm so looking forward to it.
Excellent.
And I wanted to talk about how my research and my teaching have sort of come together in a way that I think really makes a difference.
Excellent. All right. I look forward to hearing it.
So, as you know, I work on dopamine, and I have my own ideas about what dopamine does as a model. I think dopamine is not a stimulant, it's an incentive, and so it works differently. You know, if you have more and more of a stimulant, you're just more and more motivated, whereas dopamine seems to work differently, where it can motivate you to do something, but once you get the reward, then you're done and you stop moving. And that's what I've seen in my crayfish. And I'll talk more about that in a bit. But with the students, I am seeing so much enthusiasm for what we're doing, and it's really fun. And I've been doing it with them outside of class, and I've just started a class doing the same work as well. And one of the things that every professor will tell you has been happening for quite some time now is the students don't do as well in the classes. They don't do as much reading. They don't do as well on the exams. They have a harder time learning the material.
You're saying this is across the board. Students are not doing as well.
As far as I can tell, every age group, every cohort is just worse than the last.
Why am I not surprised? Because does this have anything to do with just like colloquially in conversation with friends? We've been noticing that just maintaining focus has been very difficult.
Absolutely the focus. Yeah. And I mean, COVID absolutely was also part of it. It just sort of made time move faster for a little while in some ways. Well, other ways it moved a lot more slowly. Yeah. It's that lack of focus, and it really is, I think, the screens. There's other factors. We've talked about things that have changed the way people behave in the modern world, but the constant rewards of those screens fit into my dopamine model very well. If dopamine was a stimulant only, and you got flashing lights and ringing bells from your phone all the time to reward you for interaction, you would just become more and more motivated all the time, and you would never lose focus on anything. But what actually happens? The exact opposite of that. And so why is this happening? Every time you get a dopamine reward, it's like, okay, so I use the donkey and the carrot model. So the donkey is chasing a carrot, and when it catches the carrot, it sits down and eats the carrot, right? So as long as it sees a carrot, it will run forward. But when it catches the carrot, it sits down and eats it. So what is this phone doing? It's giving us carrots all the time. And so we're constantly relaxed. I got my dopamine hit. And then, find the next carrot. Relax, I got my dopamine hit. Find the next carrot. And so we're in this constant driven cycle. People call it doom scrolling, all of this. And what is happening? We've got these constant bursts of dopamine rewards. And so what does our brain do? It starts down regulating the receptors. We're not noticing the dopamine in the same way.
So I'm sorry, what does that, be more specific, down regulating the receptors means what?
Good question.
Yeah.
It means that we don't have as many places for that dopamine to go. We're still making the dopamine, but it's hitting us more slowly with less of a spike of pleasure.
So down regulating the receptors means you become less sensitive to the same amount.
It's addiction.
You need more.
In
order to get
to the same place. Yes, this is what addiction is. This is literally what addiction is. And it is what our phones are doing.
And the term you use is down regulating the receptors, which is important, I think, to understand.
Yeah, so there's actual physical things that are changing in your brain in response to this constant screen time. People talk about let's try and lower it, let's do things, and that would probably work, but it's going to take months. It's not something you can do in days to grow parts of your brain back. It's just like quitting an addictive drug. It takes time for your brain to return to normal. It actually, of the things that can make your brain change, fat and sugar are actually harder to get normal after than cocaine is. You're more addicted. But that's a different issue. We'll talk about that some other time.
I mean, that sounds almost relevant because it's so easy to get addicted to these screens, and it's like heroin or something.
More like cocaine, but yes, yeah.
Almost impossible to get off.
It's very difficult to get off, and you constantly crave this stimulation. And so what does this do to you in your life? It means you need carrots. You need carrots right there in your face all the time. And so the students have a hard time. What we used to do, our model used to be, give a student a textbook, and I'll test you on chapter 1, chapter 2, chapter 3, and then the midterm will be chapters 1 through 5, inclusive. And so you read the chapters, I lecture on them, and then I test you on them. That would fail almost all the students today. That model would not work. I guarantee it, because no one would read the chapters.
I have to say that that's the way that I was educated entirely through college, and it was a freaking struggle every second. So I can't even imagine what that would be like now.
Zero chance of success. I can guarantee that. So you have to come up with a different way of approaching the material. And so what I do is I say, here is a chunk of material that is guaranteed to be on the test. And I discovered that no one's brains have changed in terms of ability to have knowledge. That isn't the problem. It's just this focus problem. If anything, students are better at acquiring knowledge. I'm able to give huge amounts of information, and the students will memorize it as long as I tell them this is exactly what will be on the test. And so I feel like I'm not lowering the standards. I'm just having to provide them a carrot that they can see right in front of their face. Here is 20 pages of definitions that you will need to know, and I'll give you 20 questions from this, and they will know them all, or a lot of them. Most of my students will.
So the ability to acquire knowledge has not been lost.
Not been lost.
But are we losing the ability to analyze and to synthesize and to create something new? Because it feels like...
if it feels like it's something you want to do. So this is what I was trying to get to, is by linking my classes to my research, linking my life as someone who has ADHD and problem focusing to my research, and then giving that all to my students so that they see what's in their lives, they see what's in my life, and they see exactly what the model is that's showing what they're doing. They appreciate this and they focus. And they are able...
Now you're even weaving the podcast in with everything.
Exactly. Yeah. So they're now able to take large amounts of information, synthesize them into this larger thesis, where I have a hypothesis that we're testing, and we're developing a theory about how dopamine works. It's a little different from the standard one that says dopamine is a stimulant. We're bringing it into our lives and seeing, how does this affect my studying? How does this affect my teaching? I definitely think this way now. Students need to have rewards that they can see for work that they're doing that's concrete, and then they do the work and they succeed. Every once in a while, it's just too much for someone. That just happens. It happens in every class. Next year, they might be fine. I don't know what's happening in their life. Things just happen. I try to never blame anyone for when they don't succeed, and I'll give them another chance the next time they try. But for everyone else, I'm giving them the possibility to succeed from the beginning by showing them what to do. Spoon feeding in a certain way, but it's a big spoon. I'm shoveling information, and then I'm making them synthesize it. And I'm showing them exactly what concepts I want them to get out of this big pile of information, and they love it. And then we're doing the experiments. We're actually taking these creatures, my crayfish, and giving them dopamine and seeing their behavior change, so I can fit what they're doing into this larger model. And so I'm giving them the background in my lecture, and then we're doing the work in my lab. And
it was evident. Fun. It was evident in the videos and the work that your students shared with us on the podcast that there was definitely enthusiasm and real focus. It was...
Well, they can see what we're doing is important, and it's part of a larger story, but there's also short-term goals that they can achieve. They're going to get a poster out of it. They're going to get the actual, publication
with what
from a real conference.
On. I mean, my goodness, I would love somebody to help me get to some focus these days. That would be great. So
from that, I wanted to talk about what we're doing in the class. Is really interesting. So many times I get my research by assuming that crayfish are human beings. And this is wrong. I know this is wrong. But it's a good place to start. So if I want to know how much dopamine to give to a crayfish, I'm like, well, how much dopamine would you give to a human being? If I wanted to see what levels were in their brain, what would be a reward level for a crayfish? And so that's my starting point. If I want to block dopamine, I'm going to give them the drug you would give a human being to block dopamine. And most of the time, this sort of works. Mistakes have been made. So, for example, when I was working with glucose, I started thinking about what could block glucose. So I came up with insulin, right? What do we use to block glucose? Insulin. I was already having difficulty with the glucose experiments. Insulin turns out to be the androgenic hormone in crayfish. So rather than blocking the glucose, I was basically giving them testosterone. Because these things are not unrelated, right? Testosterone is an anabolic steroid that makes muscle. Insulin is an anabolic steroid that makes fats. And so they work very similarly, but differently in different species that are that separated, right? Evolution is very conservative in that it keeps these molecules similar, but things go wildly off track if you think you can do something exactly the same on a crayfish as a human. So anyway,
Probably not a human.
I figured that out and modified my experiments. But nevertheless, the insulin was changing their glucose levels. I was seeing changes because of it, but I couldn't continue that work because it was way too flawed. And I don't actually know what hormone controls glucose in a crayfish. I can tell you it's not insulin. Insulin does a little bit of carbohydrate modification, but I don't know what the active hormone is. But back to dopamine. Turns out dopamine isn't dopamine in crayfish. They've replaced dopamine with octopamine. Or have they? It's not clear at all. There might be two different pathways, a reward pathway and an aversion pathway. The aversion pathway might be governed by octopamine, while dopamine might be doing the reward pathway. Some literature says octopamine completely replaces dopamine in crayfish. Other literature says, oh, no. Octopamine is actually neuroepinephrine in crayfish, so essentially adrenaline. So I'm going to do a bunch of dopamine experiments where I know what happens. I'm going to slow down those crayfish by giving them the reward. They get the carrot. And then I'm going to give them octopamine. If octopamine is like dopamine, they're going to slow down. If octopamine is like adrenaline, they're going to speed up.
But when you say we, what you really mean, when you say you mean we.
Yes.
Yeah. This is great. All right. So this is what you're all going to be doing in the coming.
Yeah. And so I have students in the class and outside the class. We're working together. We have people who can work long term. We have people who can work shorter term, but in a larger context in the class. It's really fun. And they see the point of what we're doing. No one has ever given octopamine and dopamine to a crayfish. It just has never happened. And
that's fascinating. The students will be participating in this.
Right. Because our world today doesn't include sort of fishing expeditions in science. There's very little of that.
Yeah.
We don't just go exploring the world.
Yeah.
And so to get a grant to do what I'm doing would be almost impossible. Luckily, I need very little money. My class budget covers the couple of $100 for dopamine and octopamine.
And I love
and I've got fish food.
The way you're getting as many students as possible involved in it. You have the ones who are the main participants, and then you're getting others involved as well, and everyone's getting a taste of what this is science.
Yeah, absolutely. But they're maintaining my tanks. They're making sure these things stay alive. They maintain them all over winter break. They kept everything clean.
We should say this is what science was. Now we don't know what science is becoming, but
I have no idea where things are going. But yeah, no, this is I think for me it's exciting. It seems exciting for the students, and I'm getting more work from them rather than less. I'm getting more than I've ever gotten before. I'm getting more attention than I've ever gotten before.
They would be getting more out of it as well. Like it's getting to them. Yeah. It's giving them.
But I've done research with students before. Yeah. This is going better.
Oh, better than the
previous. That's what I'm trying to say is that while other things are going down, some things are going up, and we're not paying attention to what these things are because our attention is also going. And the desire to focus on a nearby goal has increased in direct proportion to the dropping away of difficulty going to faraway goals.
Yes, I cannot read a book, but I can read magazine articles and periodicals.
Exactly. And so we're not focusing on the good part of what's happening. Our intense nearby screen level focus has gone up orders of magnitude. And we need to now understand that in our world and how to teach to that and how to do our research with that and really understand what that means to have short-term projects with real fundamental goals that you can hold in your hand quickly. And this will not just engage students, but to another level. I think it will engage everyone. Like this would be for, the business world as well. How do you make your projects in a group working together towards a concrete short-term goal? You're going to get a lot more done than something a 5-year plan might not work anymore in the same way. I don't see it working for me.
Yeah, things are definitely changing.
Things are changing so
rapidly.
I like to be
an
optimist about some of the good things that are happening and locate what those are.
Yeah.
And so that's what I'm really seeing
in
my work.
Good things happening for students are rare these days. So
this is what they have done in a good way for themselves.
This is great.
They are the best students I've ever had.
That's fantastic.
Yeah. Yeah.
Well, that's a great place to end.
Exactly. Yeah.
Right. Well, everybody, Mind Body Evolution. MindBodyEvolution.info. Check it out. There's a whole host of podcasts that you have not seen. Josh talks about all sorts of stuff.
You don't believe I'm ADHD? Look at the podcast. Yeah.
All right, folks. Thanks so much.
Yeah.
See you next time. Take care.